Previously in this course, we talked about the three primary service models for cloud for the cloud. They were infrastructure as a service, platform as a service, and software as a service. And for each one of those different service models, there are different mechanisms for storing data, different ways that we handle data storage, and certain levels of control that we have over that data storage. So I'm going to talk about how we store data in each one of these different environments and different service models in the cloud. And let's start with infrastructure as a service. So with infrastructure as a service, if you recall, the most common way to utilize infrastructure as a service is having virtual machines in the cloud. If you have a virtual machine in the cloud, there's the primary way that you're going to store data in the cloud is to have some kind of hard drive or something that appears to be a hard drive allocated to you by the cloud service provider and attached directly to the VM. And you'll manage that like any other file system. So that's probably the most common way to handle data storage when you're a virtual machine. That's not the only way to do data storage. Infrastructure as a service can also offer just storage. So you can store only data in the cloud. So rather than having a virtual machine, or in addition to having a virtual machine, you can also store just data in the cloud without having a virtual machine. And usually that storage is object storage. It's non-hierarchical, meaning that it's not a file system where you have a hierarchical file system where you have a directory and inside the directory some files. So there's no real organization to it. It's a flat structure. So every time you store some binary object with object storage, it gets stored, but you don't have any understanding of the hierarchy of that storage. You could maintain your own metadata that describes that hierarchy, but typically the cloud provider does not do that for us. So the way it works is, let's say you have a file that you want to store in the cloud. You use an API. You call an API from the cloud provider, typically a web API. So you call the API with a key, with your own API key for your user account. You pass the file through HTTP, so you upload it to them, and then they pass you back some kind of handle or a key for reference and retrieval. So they give you back a key that if you ever want to read back that file or access that file again, you provide that key to get access to that file. So you have to have that unique key. And again, that unique key doesn't have any structure to it. It doesn't give you any indication of some hierarchical structure. So all of that has to be maintained by you. And also, if you store a file to the cloud, the only way you can access that file is by knowing what that key is. Now, in some cloud providers, you can browse your key. You can browse, the objects that you've stored. You can see when you stored it. You can see some basic metadata, but you don't really know what that file is until you download it and open that file. So if you're looking for a specific file, you have to know what that key is. So typically, when we use object storage, we have some subsystem on the client side that's managing what data is stored where and what those files are. So that metadata we have to keep track of on our side. The provider's not doing that for us. And that fits very well into the infrastructure model, because with infrastructure, the cloud provider doesn't care what you're doing. They're just giving you access to that infrastructure. And we have to manage how we're using that infrastructure. So the two primary methods with infrastructure as a service, again, are having a volume directly attached to your virtual machine, which will appear as a hard drive. There's other technologies that underlie that in the cloud, but that's how it appears to us, and that's how we pay for it. So it's a fixed size typically. So you get a fixed size of space. You'll pay for that space monthly. You could shrink and expand that depending on your usage, and then your monthly fee changes. Where with object storage, we simply store files to the cloud, and they charge you by the file or they charge you by size. There's different pricing models for that. They also charge based on the performance that you require for that storage, and also how often you read that data back. So you write the data, and then you might be reading that data, and in some models, they charge you for every time you access that data through the cloud. So sometimes it's really, really cheap to store the data, but what you pay for is that egress, what they call egress, which is when you're pulling the data out of the cloud. And sometimes that's how they get you, when you're pulling that data out. So it's important to be aware of those pricing models. And that's a great discussion question, by the way, is how we handle those pricing models. All right, so those are some infrastructure storage types. So platform storage types, if you recall, the one example that I've talked about so far with platform as a storage, it's a great example, is SQL Azure is a platform, right? We talked about that. So in that case, we're storing data structured. So that's structured storage. So platform as a service, usually we have two ways we can store the data. It could either be structured, which is a database, or similar to database, and unstructured where there's no data structure. What exactly is a data structure? So, well, in programming, a data structure is something like an array or an array list or a hash table. You don't have to know exactly what that means for this course, but for some of you that are, computer science majors, you might be familiar with that term. But when we talk about structured data, that means that we have predefined columns, or we have predefined data types. So you sort of define what type of data you can store and how it's organized. It's all predefined, and you have to store the data within that structure. You can't do whatever you want. It has to fit within that structure. And that's what a database is, right? When you have a database, you develop tables. Those tables have columns. Those columns each have a data type. There's a certain type of information. So, for example, you can create a column called zip code. You expect it to have a 5-digit number, and you expect it only those 5-digit numbers to be valid zip code. So it's very structured. Whereas unstructured data is less rigid. You can pretty much store whatever you want. Sometimes it's referred to as blob storage or binary large object. So with platform as a service, you're either doing structured or unstructured storage, and usually it's through some kind of platform like Microsoft Azure, which is their Azure SQL, which is their database engine. And of course, there are other offerings out there as well. So that's platform as a service. And finally, we have software as a service. So software as a service is basically the cloud provider is managing that storage. So when we take a step back to infrastructure, when we talked about infrastructure as a service, we talked about how the infrastructure is managed by the cloud provider, but we have to keep track of that storage. We have to know what those keys are for files if we're storing them at the API. We're managing the file system if we have a virtual machine. But with software as a service, that storage is all now being managed by the cloud provider, and we're simply using applications that are using that storage. So they may be indexing that data on our behalf. They may be managing the applications that are accessing that data. So here's a good example is Dropbox, right? Or Google Docs. Well, not Google Docs, but Google Drive, right? So Dropbox, Google Drive, Box, there's a couple different examples out there. I'm sure you guys are familiar with at least one of those. And with all of those different offerings, when you store a file, you see your file name. You can have structure, so you can have, well, not structure, but hierarchy. You can have a hierarchical structure. So you can have a root folder, and inside that you can put stuff. You can organize your files in that environment. So they're kind of managing that for you and giving you sort of a virtual file system. So that's an example of software as a service. So something like Dropbox or Google Drive would fall under software as a service. However, infrastructure as a service storage is a lot different because we have to manage all that. So those are the primary differences. Now, once we start storing data into the cloud, we have to think about some of the threats to these different storage types. So some of those threats in the cloud, unauthorized access becomes a much more acute threat because we don't have as much control of that access. If we're calling an API to store our data, somebody else could call that API and pass the same credentials and access the data. They no longer need physical access to our data centers to do that. There's data leakage and exposure. So there's data leakage could happen. And data leakage, by the way, is when our data is exposed somehow without our knowing it. That could be exposed to some kind of malicious intent, or it could be accidental exposure of data. And it happens all the time. Think about some companies who have, let's say you had some private documents within your company and somebody accidentally posted them on your public website. These things happen all the time. That's data leakage. So all of a sudden, this proprietary information is now publicly available. Whether or not anybody in the public found it and used it or downloaded it is something you have to sometimes figure out. But that is data leakage. Then you have denial of service attacks, which can affect our use of storage in the cloud. And then question mark on destruction, because how do we destroy that data, which we'll talk about with retention and deletion later on. So some of the countermeasures we have. So data loss prevention is probably one of the most common countermeasures, or automated countermeasures for data leakage, which is data discovery and classification on networks. And there are tools that can do this. There's enterprise tools that can do data leakage protection, and we'll talk more about that in the next slide. But that can monitor. You can use the DLP to monitor the usage of data, monitor where data is stored, monitor if it's anywhere that's publicly accessible, and you can enforce data security policies. So you can enforce, for example, having encrypted data. A good example of that is I work with a lot of hospitals now that if you try to send an email that has protected patient information, so the DLP actually monitors outbound email, and if it sees that your email has information about a real patient, and it does that by cross-referencing the electronic systems where they store patient records, then it automatically blocks that email, or it automatically flags the user and tells them, hey, you can't send this unencrypted, you need to do something to encrypt that data. And sometimes they'll have a safe word so you can bypass those filters just in case you really need to get that data to somebody, which occasionally happens in healthcare. So there's different tools to do those sorts of things. So when we talk about data leakage protection, we have data at rest, which is DLP on a system that's managing data storage. Data in transit, which is monitoring the network perimeter, such as email or the web, right? So we're looking at websites that are exposed to the internet, SharePoint that might be exposed to the internet, and so forth. And then data in use, which is monitoring at the access point. But this can be challenging today because of all these different devices we have. If everyone has Windows, it's easy. There's tools that can do that. They can integrate with our enterprise platform. But now everybody has Android and iPhone and tablets and iPads and Mac and all these different devices, Linux devices, and who knows what. So sometimes it's hard to manage that on the platform, on not the platform as a service, but on the platform the user is using, because we don't always know or have tools available for those technologies. So in the cloud, a couple of the problems with the with DLP in the cloud. So these tools are available and can be used in the cloud, but we have lots of different types of storage. So in your own data center, in a traditional data center, most storage is on volumes, right? So we don't have APIs that we're calling. We don't have object storage. There is usually not this non-hierarchical storage or unstructured storage. It's all pretty much just file systems on hard drives, and these tools, these DLP tools, are designed around that. But when we move to the cloud, a lot of these DLP tools may not be capable of interrogating systems using these different storage mechanisms that we've talked about. So that's certainly one concern. So you may have an existing solution for DLP that you can't expand to the cloud because it's not cloud aware. It doesn't understand the protocols and the mechanisms that we've talked about. Here's one of the other major problems is that one of the ways that DLP works is it's constantly going out and reading files. It's constantly going out on the network and looking at files and trying to make determinations as to, whether the files need to be reclassified or if they're appropriately stored and so forth. So if you recall from earlier when I talked about infrastructure as a storage and I talked about object storage, for example, I said that one of the ways that they kind of get you is it costs very little to store the data, but the reading back of the data, the data egress costs significantly more money, especially if you do it a lot. Well, egress is anytime you're reading a file. And DLP has to read files in order to make a determination about that file, which means that DLP is constantly polling all that storage. So that means if you have a DLP that's constantly running, it's going to be constantly racking up charges on accessing that data if that's in fact how you're being billed for that data. So that's certainly something to keep in mind. If you're implementing DLP in the cloud and you're paying for your data based on egress, then you want to be aware how that's going to impact your usage of that data and subsequently how you're going to get billed for that data. It's kind of like the power company. It's not magic that that our houses get cool in the summer. It's because we turn the air conditioners on, but kids don't know that. And they say, hey, I'm kind of hot, so I'm going to turn the air conditioner down because I've seen mommy and daddy do it. And then all of a sudden you get a $1,700 electric bill because they kept the house at 64 degrees all day. Or they leave the refrigerator door open, right? But all of a sudden you get this huge bill, and that's something that you want to try to mitigate is understanding how these tools work to know how it's going to affect your utilization of the cloud.